Hello dear students, now we discuss on the example 1.6 of NCERT. According to the question, find the net force on the charge Q which is situated at the central O. Okay, so we can calculate how we can find the charge on net force on the charge Q. Suppose this is an equilateral triangle and length of each side is L. Now we can find total charge at point O. Suppose the magnitude of these charges is Q and the nature of the charge is positive. Resultant force is applied on this charge is this. Suppose this is force Fa, and similarly repulsive force applied by the charge Q which is situated at B on the charge Q is in this direction. This is the force Fb. This is an equilateral triangle, that's why each angle of the triangle is 60 degree. And this is the bisector, so this angle is 30 degree. Okay, and this is also 30 degree. Then the sum of the angle of each angle, total sum of the angle is 180 degree. Then this is the 30 degree, 30 plus 30, 60. Then this angle is 120 degree. So this is the 120 degree angle. Okay. Now the resultant force applied by the two charges on this charge is in this direction, and the magnitude can be calculated by the formula of parallelogram law. FO is equals to FA square plus FB square plus 2 F1 F2 cos 120 degree. Magnitude of force Fa is equals to Fb is equals to Q upon, let me the distance from A to O is R. Similarly, this distance is also small r, so R square. The magnitude of both forces are equal because the magnitude of charges are equal and distance are equal. That's why magnitude are equal. So we can calculate FO, or in another way we can write FAB. FAB is equals to FA FB is also FA square because FA equals to FB plus 2 FA and FB, 2 FA square, and the value of cos 120 degree equals to minus 1 by 2 under. So FAB is equals to FA square plus FA square minus FB square. This 2 to this 2 cancel, and this FA square to this FA square cancel. So FAB is equals to FA. This is the magnitude of forces applied by the A and B at point O. Okay. Now the next condition is the force applied by the charge which is situated on C is applied along this direction, right? And this force is acting in this direction. So we can calculate FC is equals to Q upon, and this is also distance R square. Then we can say FC is equals to FAB, FC and FAB, and is equals to FA and FA equals to KQ upon R square. Both forces are acting in opposite direction. That's why resultant force on this is in opposite direction, so we can use here minus sign. That's why the resultant force on charge O is 0. This is the solution of example 1.6. Okay, now we discuss on the next example of NCERT 1.7. 1.7. According to this question, find the resultant force on similarly three charges are here. Equilateral triangle, magnitude of this charge is plus q, similarly plus q, and the magnitude of this charge is minus q. Suppose this is point A, B, and C. Now the question is, find the magnitude on each charges. Find the magnitude of force on each charges. Okay, let us solve it. This q charge, applying the force on this minus q, is nature of the force is attractive force. Okay, and this plus charge is also attract this minus q charge. Then the force of this direction in this direction, it is a F BC, and this is a F AC. It is an equilateral triangle, that's why this angle is 60 degrees. Now the resultant force on charge, the resultant force on charge minus q charge is FC is equals to FA square plus FB square plus 2FA FB cos theta under root. Here FA equals to FB is equals to Q upon R square. Let me the separation between length of the side is R. This is an equilateral triangle, that's why each side is R. So FC is equals to under root of FA equals to FA, FB equals to FA plus 2FA square, because FA equals to FB. Cos theta, theta equals to 60 degree. So cos 60 degree. And the value of cos 60 equals to half. So FC equals to under root of FA square plus FA square plus cos 60 equals to 1 by 2 FA square plus FA square plus 2FA square cos, value of cos 60 equals to 1 by 2. 2 cancel, then it is equals to F A square. Now the resultant force on this is cos 60 equals to 1 by 3 F A square is equals to root 3 F A, or root 3 F A equals to K Q square upon R square. This is the resultant force on charge C. Similarly, force applied on charge A by charge, net force applied on charge A. The direction of this force is A applied on the force is this. B repelled to this charge in this direction, and this charge attract to this charge in this direction. This is FB and it is FC. And this angle is, because this is a 60 degree angle and it is 180 degree angle, so this angle is 120 degree. Now force on A. So FA is equals to root FA is equals to root FB square plus FC square plus 2FB into FC cos 120 degree. FA, here FA is equals to FB is equals to FC equals to KQ square upon r square, because the magnitude of charges are equal but nature opposite, and the force is depend only on the magnitude of charge and the separation between them. So the magnitude of forces are equal. Now we can put here values FB plus FB plus 2FB into minus 1 by 2. 2 cancel. So minus LB square cancel out by these two terms. Now the resultant force on C is FB. So FA is equals to FB, and it is equals to KQ square by R square. Similarly, the magnitude on the B charge is this. B attract to C in this direction, and this charge repel to this in this direction, and the angle is also 120 degree. So by this method, similarly this method, the resultant force on B is equals to FB FC square, and FC equals to KQ square by R square. Okay, FB is the magnitude of KQ by R square. This is the force applied on B. Force applied by the B. Sorry, this is equals to FA. Okay, FA equals to FB. Okay, sorry, FB square. This, and this is equals to KQ by R square. Similarly, this is also solved by this method. That's why the magnitude of forces is, resultant force on this charge is KQ by R square, and resultant force of this charge is also KQ by R square. Okay, this is the solution of example 1.7.